Hello, grade 12s. Welcome back. Welcome to the first video of 2025. Congratulations for making it this far. And for those who are rewriting, hello, guys. I hope this video is helpful to you, and thank you very much for tuning in. And those who are returning, who were in grade 11 last year, thank you guys for coming back. And those who are new, welcome, and I hope you subscribe so that we can be your academic partner for this year. Now, don't forget to like, comment, and subscribe to the channel. And without wasting any more time, let's get into the video. So guys, in grade 12, the first topic that you will be doing, or maybe the teacher might decide not to start with it, but it's organic molecules. So you have to know the first topic will be organic molecule. It's also called organic chemistry, right? And so we know that when we talk about something that is organic, it's something that has not been filtered, it's something that is natural. And then when we're talking about molecules, we're talking about atoms or elements, two or more atoms or elements bonded together. Now, an element, we see it in what? The periodic table. So that is an atom or an element. So when we take carbon and hydrogen, or or carbon and fluorine, or whatever two elements, we bond them together to make them one thing. That's what we call a molecule. Now, with organic chemistry, organic molecule is carbon containing molecules. So everything is being bonded with carbon in all the molecules that we'll be working with. There will always be carbon. So it's a carbon containing molecule. So those molecules contain carbon. It may be carbon bonded with hydrogen and fluorine, let's say, for instance. Okay, so just know that it's carbon containing molecules. Now, with regards to organic molecules, you have to know physical properties of molecules. Physical properties, not of molecules, sorry, a physical property of a homologous series. So we'll be doing 9 homolog series, and those homolog series, you need to know their physical property, their functional group, their organic reaction, the molecular formula, their plastic and polymers, the isomers. You have to know about isomers. You have to know how to name and how to do a formula. You need to know structural formula. So there's a video that I did last year where I talk more about molecular formula, not molecular formula, sorry, functional groups. I talked a whole lot there about functional groups. So that video will be linked in the description box. I will just write functional group link video in the description box. It's there in the description box, so just check it out, where you'll be learning more about functional group. But watch this one first. After watching this one, then you will go and watch the functional group one. It's detailed, so I don't think there's no need for me to repeat it again for you, because it's already there. So I'll just link it in the description box. Just click on the link and it will take you straight to that video. And then we also, in this video, but in this video, I'll just do homologous series. I'll show you what are the 9 homologous series. I will do the molecular formula. I will do the molecular structure. I will do the isomers, I will do physical properties, and I will do hydrocarbons. So that's all that we'll cover in this video. Yes, so let's first learn about the 9 homologous series. Sorry. So these are the 9 homologous series that we'll focus on. So the first one is alkanes. Okay, the first one, as you can see here, we have alkanes, we have alkenes, we have alkynes, we have haloalkanes, there's alcohols, there's aldehydes, there's ketones, there's carboxylic acids, and esters. So when you ask what are the 9 homologous series, these are the one. So with this 9 homologous series, we will know each homologous series molecular structure, molecular formula, and so on. So here we have dealt with the first thing on the list that we need to know, which are the 9 homologous series: alkanes, alkenes, alkynes, haloalkanes, alcohol, aldehydes, ketones, carboxylic acid, and esters. Make sure that you know them by heart. Is very, very important. It may sound like a lot of work, but it really isn't. And then the second thing that we will focus on is the definitions. Yes, so these are the definitions that you have to know. Jot them down somewhere to take notes. Well, what is an organic molecules? It's are molecules containing carbon atoms. That's the first one. What is a homologous series? It's a series of organic compounds that can be described by the same general formula and where each member differs from the next by a CH2 group. And then you have to know the general formula. What is the concept of general formula? It's an expression used to indicate the distribution of atoms in an organic compound in a homologous series. So the general formula just describes how much carbons do we have in that structure, in that molecule. We have how many amounts of carbon and how many amounts of hydrogen, let's say, because it's about bonding two molecules. But we deal with covalent bonds. Covalent bonds are bonds between nonmetals. Both carbon and hydrogen are nonmetals. So with this one, we're going to be bonding with homologous series. We're going to be bonding covalent bonds, dealing with only covalent bonds. So it's going to be bond between non-metals. So you have to know that the general formula will just tell us how many carbons we have, hydrogens we have, maybe fluorine or whatever, depending on what atoms are bonded together. And then the functional group is an atom or a group of atoms that determine the chemistry of a molecule. Okay, so that is how we identify whether this homologous series is ketones, is an ester, it's alkanes, it's alkenes, it's alkaline, it's carboxylic acid. We see that by a functional group, which is a video that I will be showing you next, how to go about that. It's more in detail. It covers actually a lot, so please click the link on the description box to take you to that video. And then we have hydrocarbons. Those are organic compounds containing only hydrogen and carbon atom only. Okay, atoms only. So when we are talking about hydrocarbons, you know this molecular structure will only contain hydrogen and carbon. That's a hydrocarbon. Yeah. And then we're going to talk about unsaturated hydrocarbons. So unsaturated hydrocarbons contain covalent double or triple bonds between the carbon atom. I hope you know double bonds and triple bonds in grade 11, but if you haven't learned them, it's not a problem. I am going to link the video in the description box where you learn about intermolecular forces. If you haven't learned about intermolecular and intramolecular forces, I will link a video in the description box so that you go and recap on the grade 11 work, because it's quite important that you do for you to be able to understand everything about organic chemistry. And then we have saturated hydrocarbons. So saturated hydrocarbons contain only single covalent bonds between carbon atoms. Now just going up a bit, Here are your hydrocarbons. I hope you're writing notes. You have hydrocarbons. Your hydrocarbons is alkanes, alkenes, and alkynes. Okay, those are your hydrocarbons. But for a saturated one, we only have alkanes. Alkanes are saturated hydrocarbons, and then alkenes and alkynes are unsaturated. Alkanes is saturated because there is a single carbon to carbon. So that line in the middle, we have C bonds only. And then alkynes and alkenes are unsaturated because they have one or more multiple carbon to carbon bonds. So there are two lines between carbons, while in the saturated one there's only one bond line connecting the two carbons, but in the unsaturated there are two lines connecting the two carbons, or let's say the two atoms. I hope that is clear. So another thing to take note of, that keywords should be taken into consideration in definitions. So when you define something, just like here, there are keywords, and for that we will use the examination guideline. So I hope you download the examination guideline. Go on Google, type physical sciences grade 12 examination guideline, and it will pop up. Just download it, have it on your phone, and use guideline for definitions. How to represent organic molecules. I'll see if I can get a link to it. I'll put in the description box, but if I don't, then it's fine, but I will try. But that is how you download it. So you also have to know how to represent organic molecules, but that one I've done in that video that I said you should check in the description box, where I have done functional groups. So here we are. The difference between a structural formula and a molecular formula. There is a difference, distinct one. When we're talking about a structure is this thing that you see on the left hand side, where there are, how many C's do we have there? We have 4 carbons with let's count the hydrogens. There are 10 hydrogens. So there are 2 carbons, not 2. There are 4 carbons. On your right hand side, where they say molecular formula, can you see butane? They say butane has 4 carbons and 10 hydrogens. That is a molecular formula. That's how you write it. You just look at the number of carbons and the number of hydrogens. Okay. With ethanoic acid, they didn't show the structure, but in that structure there are 2 carbons, there are 4 hydrogens, and 2 oxygens. Okay, so that is how you see the difference between a structural formula and a molecular formula. So a structural formula shows which atoms are attached to which within a molecule, and then atoms are represented by their chemical symbol. Lines are used to represent all the bonds that hold the atoms together. And then with molecular formula, indicate the type of atoms and correct number of each in a molecule. So in this molecule, how many carbons do you have, and how many hydrogens do we have, and how many oxygens do we have? That is a molecular formula. Okay, you're not drawing. So tips on drawing the formula: make sure that carbon atom is surrounded by 4 bonds, not more, not less. You see, they are surrounded by 4 bonds. The first carbon is surrounded by hydrogen on the top, hydrogen on the left, hydrogen on the bottom, and on the right hand side is surrounded by another carbon. And then the middle carbon, the second carbon from your left, the upper one is bonding with hydrogen. On the left hand side is bonding with another carbon. On the bottom is bonding with another hydrogen, and then on the right hand side is bonding with another carbon. So that's what they say when you are drawing. Make sure an atom is surrounded, a carbon atom is surrounded by 4 bonds, not more, not less. All bonds must be drawn. Hydrogen atom should not be omitted. Functional group should be placed at the correct position. Use a general formula to generate the molecular formula. So I will tell you all about functional groups in the video I have linked in the description box. Please check that out. It's very important. When asked to write molecular formula, do not draw the structural formula. Just as I say, the molecular formula is just to tell us in the structure, in an alkane, let's say, just hypothetically speaking, it's not like that. In an alkane, we have 4 carbons and 10 hydrogens. So that is a molecular formula. But when they say a structural formula, you draw that structural formula. They will tell you what to draw and you draw it. Okay, so write down what are the following examples. This is a worked example. Write down what are the following examples are showing the molecular formula or the structural formula for the organic compound from A to B. Which one are they showing? It's a molecular formula or a structural formula. Structure, remember, whenever they say structure is a stone, structure is a building. You did technology, right? So you know a structure is A, a formula is B. Okay, so keep that in mind, guys. So you can test yourself here. You can test yourself to know if you know a structure and a formula. Yeah, these are the homologous series that we have dealt with. Now we are going to show you how do you know an alkane, an alkene, alkaline, haloalkanes, alcohol, aldehydes, ketones, carboxylic acids, and esters. How do you know them? We identify them by their functional group. So we are just going to do a little bit of it here just to show you what is what. But that video in my description box, it's very important. Please watch it. Okay, functional group is an atom or group of atoms that determine the chemistry of a molecule. So the functional group for all homologous series must be identified from structural formula and name to organic molecules. So the homolog series, functional group, and general formula, its name, it's in this table. So we have alkanes, which is the first one. We see it when we only see hydrogen and carbon. We only see hydrogen and carbon bonds, and there's nothing else in that structure, like this one. This is an alkane. Okay, that's how you identify it. And then alkenes, they are double bond carbon. There's a double bond carbon. So there are 2 lines connecting carbons. You know that is an alkanes. Alkenes, there are 3 lines, triple bond, bonding 2 carbons. That's how you see it. A haloalkane, there will be CNH, and then on another branch, you will see where carbon is bonding with either fluorine. Let's do this. You will see it bonding with either fluorine, chlorine, bromine. Yeah, you see it bonding with either is the group. They're in group 7, those atoms. Iodine with iodine, astatine or tennessine, with either of those. If you see the structural formula, but there is also carbon bonding with either of the group 7 atoms, then you know that is the haloalkane. Okay, there will be carbons, hydrogens plus 1 of the group 7 atoms. So for you to identify an alcohol, you will have C at the end will bond with OH. C at the end, the carbon will bond with OH. Let's see here. Here we have, oh, it's only bonding with O. so it's not it. Yeah, I was trying to look at the structure. So it's an alcohol. C and OH. OH is at the end. That is alcohol. And then we have aldehydes. Yes, aldehydes is a triple bond between carbon and oxygen, and we see it on the structure. Can you see that there is a double on that part? There is a double oxygen bonding with carbon there. That is what will be the functional group. That's what will be the functional group. Yeah, I'm trying to mark it. Pen. Okay, yeah, this CNO is the functional group. So that's how you see this is a functional group, and then you can be able to identify, oh, this is what, this is what. Another functional group can be this OC. That is a functional group, but without those things, carbon and hydrogen just bonded together, it's alkane, we know. So that is how you identify the functional groups. But on that functional group, I did a very detailed video, but just for introduction, so that when you get that site, you already have a clue. And then we have ketones. And then ketones, the functional group of ketones is the same as aldehydes, but their positions are not the same. Okay, so with ketones, the double bond of C and O might be in the middle, while with aldehydes it's not in the middle. That is, you say that C maybe it's also bonding with hydrogen. So it's just about the position. Just look at the video. And then we have carboxylic acids as well. We have, oh, this one is a total carboxylic acid. Yeah, this structure is a total carboxylic acid. Is a combination of two other homologous series make up carboxylic acid. So this is a carboxylic acid. If you can see here, we have OH. OH is alcohol, and then a double bond of C and O is aldehydes, okay, or ketones. So can you see there are two homologous series in one structure, so they make up carboxylic acid. And then we have ester. Ester also has O C double O C bond. Oh, let's see, is there H in here? Yeah, this is bonding with H as well. Yeah, this is how you can see that, oh, this is actually an ester. All right, as we have done hydrocarbons, this is just another example of hydrocarbons. Are compounds that consist of hydrogen and carbon atoms only. So here we have them. You see, all of these things are hydrocarbons. The first homologous series that we talked about, alkanes, alkenes, alkynes, they are all here. And then the difference between saturated and unsaturated. So a saturated hydrogen only contains single covalent bonds. Covalent bonds are bonds between nonmetals, and those are your example. Unsaturated is the first one, alkane, and unsaturated carbons. Here they are. This side contain double bond or triple bond. Anything that has double bond or triple bond is unsaturated. And then worked example, identify the following compound as saturated or unsaturated. Here we said it's unsaturated because it has carbon triple bonds, and then here you can test yourself. Well, they are double bonds, so you can tell what is that. Also, you have to know the naming. I will do that in the next video, which will be next week. Next week I'll post another physical science video where I show you how to name the different when you're given a structure, how do you name it. We'll cover that in the next video. And then this organic chemistry has a section 2 of it. So on the section 2 part, remember the naming, I will show you, it's such a process, so we have to do it step by step together to know how to name. But yeah, we'll do it on next week's video. So now again, one thing you have to know is the physical properties of organic molecules. It's the another section. So here we're going to be talking about melting point, boiling point, vapor, pressure, and viscosity. So when we talk a bit about intermolecular forces, are different forces, right? We can have a force, the forces that are called, when we're talking about intermolecular forces, are forces between molecules. So we have forces between remember, a molecule is two atoms or elements bonded together. That is intramolecular forces. Remember grade 11, I'm going to link that video in the description box. And then when you have molecules, two molecules bonded together, those are intermolecular forces. So there are types of intermolecular forces. Number one is what we call dipole forces. So it's between two polar molecules. We have mutually induced dipole forces. Those are London forces. They are the weakest. So they are between two non-polars. Forces between two non-polars. We have dipole induced dipole forces between a polar and a non-polar. We have ion dipole forces between polar and an ion. We have ion induced dipole forces between ion and a non-polar. Okay, so that's what you have to know. In that video, I covered it so well that it's easy to understand. Okay, I did it last year. So please guys, I will link it in the description box. I will call it grade 11 intermolecular forces. It will definitely be there. I'm telling you the truth, so please go and check it, because I really want to help you guys, that we leave no stone unturned. This metric here, it's yours. Yeah, what I like about YouTube is that resources are available, and even if you can't afford a tutor, it's not that bad. And then the concepts that you have to know is boiling point. When you ask what is boiling point is the temperature at which the vapor pressure is equal to the atmospheric pressure. These descriptions that are written here look like the ones in the examination guideline, but you have to have the examination guideline. So melting point is the temperature at which the solid and liquid phase of a substance are at equilibrium. That is melting. Okay, vapor pressure is the pressure exerted by a vapor at equilibrium with its liquid in a closed system. And then viscosity is the resistance of a fluid, which is liquid or gas, to flow. So you should know this concept. Remember in grade 10 when you did was it an atom chemistry, there is where you did melting point, freezing point. So yeah, remember that as well. So we have to look at those intermolecular forces are electrostatic forces. So intermolecular forces are electrostatic forces between molecules which make substance. So types of intermolecular forces in the homologous series. With alkanes, alkalines, you can either have, sorry about that. It's 12 o'clock midnight, I'm recording. You can either have induced dipole, dispersion, or London forces. Okay, so those are the forces, the intermolecular forces that you can get with these three. And then with haloalkanes, aldehydes, ketones, and esters. The forces that you can get is induced dipole, disperation, London forces, and dipole forces. And then with alcohols and carboxylic acid, the forces that you can get is induced dipole, disperation, London forces, dipole forces, hydrogen bond, and London forces. So hydrogen bond are the strongest bonds. London forces are the weakest intermolecular forces. So comparisons of strength of the intermolecular forces, here it is dipole, it's London, dipole, London is less than dipole forces. Yeah. So dipole forces is less than hydrogen bonds, okay? So it's London forces, and then comes dipole forces, a bit stronger. London are weak, dipole are a bit stronger, medium. Hydrogen bond are like the strongest. So factors affecting the strength of intermolecular forces. What can make an intermolecular force strong or weak is the chain length. The longer the chain, the stronger the London forces, or the shorter the chain, the weaker the London forces. So the longer the chain, the stronger the London forces. So the more carbons we have in a structure, the stronger the London forces. Okay, so the less carbons, again, the carbon makes up the chain of the structure. So the more those carbons, the stronger the London forces. London forces are weaker, but they can be stronger, a bit stronger in a long chain. And then we're going to talk about branch chain. The more the branches, the weaker the intermolecular forces. Okay, so that one of branches, you see branches in that when I am drawing, we have branches. So I will try to see if I can find a branch. Let me see. All right, you see on number D, there's a chain of carbons. This one that is going down, this is a branch. So when there's something like this branch is weaker, but this one on the right, it's stronger. The longer the chain, we have many carbons, so that is stronger. That's what I meant. Yeah, so we have number and type of intermolecular forces. Those are hydrogen bonds are stronger than dipole and London forces. And then we have dipole are stronger than London forces for the different homologous series. So the relationship between physical properties and intermolecular forces. Okay, so boiling point, physical properties and relationship to intermolecular forces. Boiling point increases with increase in strength of intermolecular forces. So as the intermolecular forces get stronger, the boiling point also increase. The strength it takes to boil that molecule is higher. So the melting point increase with increased strength in intermolecular forces, or decrease with decrease in strength of intermolecular forces. So if the strength of the intermolecular forces decrease, then the melting point will decrease as well. Viscosity increase with increase in strength of intermolecular forces, or decrease with decrease in strength of intermolecular forces. So the viscosity will decrease, depending on the strength of the intermolecular forces, whether it's London, dipole, or hydrogen bonds. So vapor pressure increase with decrease in strength of intermolecular forces, decrease with increase in strength. So the vapor will increase if the strength decreases, and the vapor will increase if the strength the vapor will increase if the strength of the intermolecular forces are low. They decrease, and the vapor will decrease with increased intermolecular forces. So tips on explaining the relationship between physical properties and intermolecular forces. Compare the structure, chain length, number of branches, or a type and number of intermolecular forces, and compare the strength of intermolecular forces. So tips on explaining the relationship. When a question in an exam says explain the relationship between the intermolecular forces, so these are the things you need to include there. You can compare energy needed to overcome the intermolecular forces, conclude on the physical property, is it higher or lower, after talking about the strength, the structure, and the energy needed to overcome the intermolecular forces. Mention the compounds and the intermolecular forces of the compounds in question. And then comparative words to use when the relationship between the strength of intermolecular forces and physical properties. So you must use longer, more, stronger, or higher. Tips, the trends in boiling points, melting point, vapor points, and viscosity. The higher the chain, the higher the melting point. Carboxylic have more sites of hydrogen bond than alcohols. The stronger the intermolecular force, the higher the boiling point. The weaker the intermolecular force, the stronger the vapor pressure. Thank you very much for watching, guys. On the next video, we'll do section 3. The next video, I said on the next video, I'll be showing you how to name. So that week, the third week, maybe it's the week of the 20th, I will be doing organic reactions. I'll post the video, same time, same place, Wednesday. Have the look on that. Thank you very much for watching. Don't forget to like, comment, and subscribe. Until the next one.